Welcome to Mathematics for Principles of Economics. The topic of this video is how do we find profit on a graph?
The math behind the economics is tangents and the area of rectangles.
So recall that profit is defined as total revenue minus total cost. And knowing a firm's average total cost can also help us define profit, since average total cost times quantity produced is equal to total cost. So what if we have a graph like this that shows a firm's total revenue and total cost? How can we find profit and the profit maximizing quantity? Or we might have a graph like this next one, which shows cost and revenue curves for a firm in perfect competition. How could we find profit on this graph?
In order to answer these questions, we need to have a little bit of information and understanding about what tangents mean when we look at a graph and how we can use them in this context. So let's look at a particular example of a graph right here. And on this graph, you'll see that in gold, I have the total revenue, and in blue, I have the total cost. And profit is the distance between those. It is total revenue minus total cost. Again, the difference between those two graphs. So we see that as the black line slides up and down, that's measuring profit. That's how far apart those two graphs are. And we see that it's maximized right here on the dotted line. And if you look closely, you'll see that that maximized point is when the slope of total revenue is equal to the slope of total cost. That is, when marginal revenue is equal to marginal cost, we find that profit is at a maximum. So what else do we need to know mathematically in order to answer the questions that were posed? Well, we also need to know how to calculate the area of a rectangle. So here's a rectangle. I need to calculate the area. I need two values. I need the, I guess I normally would call this the height of the rectangle, and I need the length of the base of the rectangle. And in that case, we know that the area is the height times the base. So let's do a specific example very quickly here. If the height of my rectangle is 3 and the base of my rectangle is 5, then I know that the area is 3 times 5, which is 15.
Okay, let's answer the question about finding profit on a graph. Here, looking at total revenue and total cost, we see that on the for lower quantities on this graph, total cost is actually greater than total revenue, so the firm's making losses. So what we want to do is find the maximum distance between total revenue and total cost in the area where the firm is making profit. Okay, so what we need to do then is draw a tangent to the total cost curve to find out where the slope of the tangent would be equal to the slope of total revenue. And if we do this, we see that actually the profit maximizing quantity is going to be 12. This will be the area where the firm is making the most profit. If instead we're looking at marginal and average curves for a firm, recall that a profit maximizing firm is always going to produce the quantity where marginal revenue is equal to marginal cost. So we know that the firm is going to produce the quantity of 12. With this information, then we can find total revenue and total cost. So when the firm is producing a quantity of 12, we note that price is equal to $5. Price times quantity is total revenue, so the area of our total revenue rectangle is $60. Okay, now looking for total cost at a quantity of 12, because this is where marginal revenue is equal to marginal cost, we note that average total cost is $4. So the area of our total cost rectangle then is $48. Okay, we can use this information to find profit. Total revenue minus total cost, 60 minus 48 is $12. And note that we can also see a profit rectangle here where we see that area is $12, representing $1 times a quantity of 12. Okay, other times we can find profit on graphs. We can look at market structures other than firms in competition, such as monopolies, oligopolies, and monopolistic competition.
Now we've seen how to use the math behind the economics to find profit on a graph. Thank you for listening.